part of my work as the nomination process for GERAD membership. I would like to thank my colleague Matt, who's attending the seminar online. He's the one who initiated the process, although I think I had to push him a little bit too hard to start the process. And of course, Olivier and Madeline for making the arrangements. For today, I have chosen to focus on sustainability. And the reason is I want to focus my collaboration with GERAD on the particular topic of sustainability. And that's for a few reasons. One is sustainability has been the focus of my work in the past few years, especially in fast fashion and agricultural supply chains. The second is that, as Olivier mentioned, I am the director of Sustainable Growth Initiative. This is an initiative that we put together in 2022 at Desautels with the goal of reaching out with talent and expertise across McGill in order to address pressing sustainability challenges. And I am eagerly looking forward to create this interface between SGI and GERAD. And the third, but not the least factor, is that GERAD has this key application focus on energy, environment, and natural resources. And I believe that's where I'm going to help GERAD the most in order to develop that dimension. So with that little introduction, I would like to focus on food waste that kind of falls into agricultural supply chains and my focus on that kind of research. So food waste is a common problem. About 1.3 billion tons of food, or about 20%, or about 20% of the entire production every year goes to waste. By the way, so we have enough time. So if you have any questions along the way, please stop me, and I would be very happy to address the questions. So about 1.3 billion tons of food goes to waste. Of course, in order to produce this food, a lot of operations is involved that goes to waste. The cost of those operations amounted to $1 trillion in 2022. And in terms of the environmental consequences of food waste, 10% of global greenhouse gas emissions are due to food production, food waste that is being generated. Now, this is especially important because when food waste rots in landfills, it produces methane because it is rotting in absence of oxygen. And methane is a greenhouse gas 80 times more potent than CO2 in creating the greenhouse effect. This number is, by the way, way higher than the entire aviation industry that has been under the microscope in recent times. In terms of the social consequences, we have this amount of food waste, but at the same time, close to 750 million people in the world are living in hunger. Hunger is different from food poverty. So food poverty is when people have enough food to consume, but the quality of the food they are consuming is not what it should be for a healthy diet. But this is the number of people who are living in hunger. Now, the key questions for us would be where and why food waste exists. We can take a look at food waste along the supply chain. The food waste could happen on the farms, on the production stage and processing of food. We have distribution stage, retail, and finally consumers. By consumers, I mean households, restaurants, hotels, and so on and so forth. Now, I would like to mention a couple of points here in order to narrow down the focus of this particular paper that I will be talking about. The first one is the difference between food loss and food waste. Food loss is a characteristic of the production process. In other words, it's endemic to production processes. Whenever something is being produced, there will be some part that goes to waste, and there is not much one can do about it. One can try to minimize indeed, but it will exist nonetheless. Maybe I can draw a parallel to fast fashion supply chains, where I do quite a bit of research as well, to introduce what natural loss in production processes looks like. So, you know, when we have different models that have to be produced in a garment factory, the forms and shapes will have to be cut into the fabric. Of course, we can use OR algorithms in order to minimize the amount of fabric that goes to waste or gets lost. But no matter how we do it, that part, there is a part of the fabric that will go to waste. So this is basically what also happens in food supply chains. For example, we had recently some more than usual humidity and then a period of drought in Brazil. And that affected the yield of the coffee crops. As you know, Brazil is one of the most important countries producing coffee beans. And when we have unusual humidity in that region, then the coffee yield and the coffee quality is going to go down. This is part of food loss. One may come up with ways to minimize it, but there is not much one can do to eliminate it altogether. So food loss is a characteristic of the production and distribution stage. So it happens by and large in the upstream supply chain, usually on the farms, all the way to the distribution stage of the food. But food waste is usually a characteristic of retail and consumers, household, restaurants, and hotels, and so on and so forth. And this is because the food is ready for human consumption. It's good, it's safe to use, but then because of certain practices, for example, because of bad packaging practices, or let's say on the side of the consumers by overbuying or keeping the food in under optimal conditions, the food goes to waste without having the chance to be consumed. So that's what we mean by food waste, and food waste usually happens towards downstream supply chain. As a matter of fact, if I wanted to include food loss on top of the food waste that I mentioned previously, then about 1/3 of the entire production, about 33% of the entire production of food goes to waste every year. So the number I provided before is only food waste, not including food loss. So that's the first point. In this paper, in this project, I'm mainly focusing on food waste, which means I will be focusing mainly on the downstream supply chain, on the relations between the suppliers and retailers. Now, the second point I wanted to make is that the reasons this food loss or the food waste exists could be either economical or technological. For example, when it comes to the harvest season, farmers cannot manage to harvest the entire yield from the fields. This is because no matter how good they do, part of the yield is going to remain on the field and go to waste. So depending on where this harvest is happening, for example, developed countries versus developing countries, this waste can differ. So more technologically advanced economies will be able to have a higher yield harvest in comparison to developing countries who may not have access to the same kind of technology. So that's basically a technological reason that food may exist. It doesn't mean we cannot do something about it. For example, when it comes to this unharvested crops, we have cleaning operations. This has been also a topic of research and operations, where we can have NGOs, volunteers, that go to the farms and they actually pick up that extra yield that farmers do not need. They just let it be there and run. So these organizations can go to the farms and pick it up. So there are ways in order to try to minimize that sort of waste or loss. But the main reason that we have that kind of loss is technological rather than economical. But then we can also have waste or loss because of economical reasons. For example, farmers, in reaction to market conditions, could overplant certain crops. So overplantation means that we will have crops that will not be sold in the market and then may have to go to waste. And of course, the same thing also happens downstream. For example, retailers could be reacting to certain discounts provided by suppliers, or customers likewise could be doing poor planning in case there is something on sale. They may actually overbuy, but then they cannot keep it, and the food goes to waste before it has a chance to be consumed. In this paper, my focus would be on a combination of these two factors. So I will argue that investment in traceability technologies in food supply chains has the potential to decrease the food waste in the food supply chains. But it needs to be done in a certain way to have the desired impact. Okay, now, yes, Daniel.
The four steps contributes to the largest portion and the source of food.
Okay, interesting. Interesting. Yeah. Actually, we have good numbers for that. In terms of food waste, right? So food loss maybe happens in this stage and also in distribution, but food waste itself happens by and large with the retailers and also with the consumers, households, restaurants, and hotels. This is 40% in this stage, in the retail stage, and we have around 30% with consumers. Only 20% of food waste in the way that I mentioned is happening up the stream supply chain. So that's basically what's happening. And one of the reasons that I'm focusing on the retail stage and also to some extent with the consumers is because much of the food waste happens at that stage. Okay, so I will be focusing on a particular type of waste though. Yeah, and that is basically spoilage. So if we get back to this supply chain picture of an agricultural supply chain, we will notice that spoilage is a particular type of waste that exists all over the supply chain. So spoilage kind of refers to time temperature decay of food products. So as soon as food is produced, there is this time that it starts clicking and until it goes to waste if it's not consumed. So the idea is that problem can happen all over the supply chain, and depending on the conditions of operations along the supply chain, that could be going up or down. So as a matter of fact, 65% of the entire food waste that we refer to happens because of spoilage. So, and that is why I will be focusing on that kind of waste. 30% of the food in grocery stores is going to waste because of spoilage as well. So it's an important type of waste that happens along the supply chains of food. And our goal is, and the paper kind of focuses on that type of waste. And the reason I say that is because the way I have modeled waste, as you will see down the road, is particularly relevant to this kind of spoilage. Other kinds of waste, of course, will need different models, different ways to minimize or eliminate. Okay, so now it's not that policymakers are not aware of the problem. There has been a lot of initiatives in order to bring down food waste. So US in 2015 pledged to cut down food waste by 2030 in half. Of course, they are nowhere close to that target. Canada has had its own initiatives as well. There is no federal law to control food waste in Canada, but some provinces have had some initiatives to some limited levels of success. For example, Nova Scotia is a perhaps an exception that banned landfilling food waste or organic waste in the 1990s. So you cannot direct food waste or organic waste into landfills in Nova Scotia. There has to be some other ways of dealing with it, although that doesn't really address the existence of the waste in the first place. Okay, maybe other countries have been a bit more proactive. The example that I want to provide in here is France. They have a law by an MP, Loi Garot, in 2016. So the law bans supermarkets larger than a certain level to get rid of the unsold food. They have to donate that unsold food to charities and food banks and so on and so forth. And if they fail to do so, there will be a financial harm and possibly jail time for those violating the law. Likewise, in Italy, in 2016, we had Gara. Again, Gara is the name of the MP who came up with the law. And that one goes a little bit of a different way in controlling the waste by providing tax incentives for retailers in order to encourage them, incentivize them to donate the food rather than dump it in the landfills. So this is basically the initiatives on the side of the retailers. So again, recall that majority of the food waste happens with the retailers and the consumers. So in France and in Italy, they have tried to target the retailers. But then we also have a lot of waste happening on the side of the consumers. These are, as I mentioned, households, restaurants, and so on and so forth. So an interesting example in this case is South Korea that came up with the pay-as-you-waste system. It's a very interesting system. I would like to mention this very, very briefly. So you cannot just dump the food or organic waste similar to other kinds of waste. You will have to separate it and you will have to take it to specific bins. So these bins are going to open only with a barcode specific to that family. So they open, and once you put the waste inside the bin, it weighs how much waste is being generated and then issues a fine for the household. So you pay depending on how much waste you have generated. Of course, when it comes to implementation, they claim this has been a very significant success in bringing down the waste. But then when you look into the details in terms of implementation, this creates a lot of issues. So how do you monitor the households and how they treat the waste and issuing a fine and so on and so forth? But at least it shows that there are very interesting initiatives in order to control the food waste that is happening all over the supply chain.
What prevents also just to put this type of waste in the normal garbage?
Well, that's the point, right? So in terms of the implementation, this creates some friction. So there needs to be some sort of monitoring system to prevent a household from, let's call it, cheating the system. So for example, in case a household is not generating food waste for an extended amount of time, that's a signal that this household may not be following the rules. Or sometimes there are neighborhood watches that are trying to kind of follow or ensure that they are doing what they're supposed to do. So when it comes to implementation, as I mentioned, it's not so straightforward. They claim it's been very successful, bringing down the waste by 80, 90%. But when you look at the details, the fine print, I do believe that you will find these issues. Go ahead, please.
Very good question.
Yeah.
If I have a banana,
yeah.
I pick the banana, it's my fault if there is waste. So I would get a fine for eating a banana.
You will. So in here, of course. So let's say, for example, an interesting example is in case you are making, I don't know, some sort of soup and you are using vegetables, right? You have to clean the vegetables. So the waste that comes from that, is it basically household waste that I could have prevented somehow and I didn't? Well, those are points that I think are very interesting to look into, but that's basically how it works. So the entire food waste that goes into these bins is weighed and a fine is issued for the household. So again, it's just an example. By no means I'm trying to defend what they are doing in South Korea. I'm pretty sure that I like the idea because it shows that they are taking action to see what could be done in Hong Kong, for example. What they do is they burn the organic waste and turn it into biogas. So I believe a large factory was opened in 2019 in part of Hong Kong to turn food waste into biogas. So they don't really issue fines, but they encourage the collection of organic waste and turning it into biogas that then turns into electricity and so on. So that's the key idea in here, that different initiatives are underway to prevent food waste. So this regulation is going on. And a lot of companies, as a matter of fact, are trying to stay ahead of the curve. Now, the claim with traceability is that technologies enabling traceability in grocery supply chains can reduce or will reduce food waste. Now, this one from a code from World Economic Forum, real-time tracking supports sustainability, prevents food waste, and ensures compliance with environmental standards. For this one in 2019 in Forbes, blockchain transparency could force food suppliers to eliminate inefficiencies in the supply chain, reducing waste. And of course, we have regulations, as I mentioned, coming also in this domain. So one way, at least it's the theory, one way would be to create transparency, traceability in food supply chains, so you can identify the source of the waste and then control the waste in the source. So these two are kind of interesting in EU. So this is the original one, 2019-1381, or maybe the other way. This is the original one, and then we have which is a amendment of the law. So this one, known as the EU Transparency Regulation, is requiring partners in the supply chain to actually know who their suppliers are and who their buyers are. So they call it the one step up, one step down policy in the EU. Apparently, it's not even clear to many of these companies who their buyers and who their suppliers are. And the reason they want to do this because they want to create this traceability in the supply chain. If something goes wrong, they can track and see where the source of the waste is and hopefully control it. And likewise, in the US, we had some regulation passed on transparency in supply chains, but given the recent events, I'm not so sure whether they will be catching up on those as well. But in any case, given all these regulations coming up, some companies are trying to stay ahead of the curve. So Vino Ferrero, European company, Italian company behind the lovely Nutella. So they claim to have created an infrastructure to collect the data along the supply chains that they claim has helped them to reduce food waste. Or, for example, Track Vision, which is a London-based startup, and claiming they can install the infrastructure along the food supply chain in order to collect the data necessary in order to bring down the food waste in the retail stage. So these are a lot of initiatives. We also have large retailer stores such as Tesco in the UK, Walmart, and Carrefour in France, who claim to have moved towards creating that infrastructure in order to trace food waste and hopefully come up with the initiatives to decrease. I'm going to talk about Tesco a little bit more because I believe our research offers a little bit of insight into what they have done, which is quite interesting. I can even mention it right now. In 2017, they consolidated in the fresh produce segment of their business. They consolidated their supplier base from a number of them to only one. So this is quite interesting to me. Usually, we have supply-based diversification because of risk hedging and whatnot. But then a major company moving towards single supplier is an interesting initiative. And it kind of flies against that idea. And I believe one of the insights that we could provide is this helps control the supply chain much more. Essentially, it's a step towards vertical integration. They are not vertically integrated, but it's a step towards that picture. And they claim that this has helped them to decrease the food waste by 200 metric tons every year. Customer complaints are down by 70% because of spoilage and so on and so forth. And I think our work is going to offer a rationale that if your goal is to bring down food waste, then consolidating the supply base could be one way to push and get to that goal. Okay, now in terms of research question in this paper, I have three. So one is whether information sharing along the supply chain will help decrease spoilage waste. That's the first question that we have in mind. The second one is whether this effect is going to depend on the scale of information sharing. And lastly, even if we assume that this information sharing in some form, in some extent, is helpful to bring down food waste, whether the incentives exist along the supply chain to actually move towards information sharing. And if not, then how can that incentive structure be created? So these are the key research questions that we are looking into. I'm not going to drag you in the model too much. I'm just going to offer the highlights, and I'm hoping that the intuition is going to come through. And one other comment is that I'm actually revising the paper right now. So the model that I may mention a few things that are not in this model, but are in the revised model. But I couldn't finish the revised model on time to kind of include in this stuff. So I will be using the old model, referring to some insights from the new model if necessary. Before we get into the model, though, I would like to mention some key papers in the literature. So in operations management, we have had different streams focusing on traceability or food waste. So when it comes to supply chain traceability, recently we have had a number of papers that are looking into traceability, in particular blockchain, and how it could help in different settings. The closest to ours is this paper by Bora Keskin and his colleagues, looking into blockchain technology and the smart contracts in order to bring down the waste at the retailer and consumer's side. These two papers by Chui and his colleagues, they are looking into how traceability can help avert the moral hazard problem in the supply chain. And of course, by eliminating that inefficiency, certain types of waste could be avoided. But the key point is that supply chain partners could not be necessarily aligned in adopting traceability of blockchain technologies, because the key question is who gets the benefits and who gets the short end of the stick. So that is going to be a key problem also in our setting. So we will see the party that benefits is not necessarily the supplier who's supposed to share the information. And if that is supposed to happen, then certain incentives must be installed in the supply chain. We have, of course, quite a bit of work in terms of perishable food supply chains as well. So food waste has been a recent focus in operations. Perhaps a couple of papers by Elena Della Vina are quite interesting to look into, in the sense that she looks at the waste with the consumers and the impact of the density of stores in a city on how much consumers end up wasting the food. So those are quite interesting in terms of consumer behavior. And we have quite a bit of papers on perishable food supply chain by Dorothy Honhon, Arzu Makash, and others. And of course, inventory operations management has a long history of modeling perishable inventory products. There's a number of them. I would like to mention a couple of them in here that are explaining why the model that I'm going to present shortly actually makes sense for spoilage. So these papers in here, especially the one by Limbo et al., show that spoilage is proportional to the amount that is being shipped along the supply chain. So these papers are empirical, kind of providing a nice ground for why it makes sense to use a proportional decay model to model spoilage waste in supply chain. Okay, so now let's jump into the model and see what the model structure is. As I promised, I'm not going to bore you with the details, but just the structure of the overall model, which has also been revised recently. So in here, I have a supplier and a retailer. The supplier is putting the order to its upstream suppliers. The order quantity is I, but from this order quantity, only a proportion of it becomes available for forward to the retailer. So part of the supply, 1 minus theta, goes to waste. So, and we have the retailer who is doing similar. The retailer is facing an unknown demand, an uncertain demand with the consumers. So an order quantity of Q is put to the supplier, but only, of course, the minimum order quantity and the supply is being shipped to the retailer. Now, in here, the retailer satisfies the demand, and afterwards, there is a part of the remainder that goes to waste. Of course, we can also have clearance with the retailer, and in case that doesn't happen, then you're going to go to waste. So that's basically the entire model that we have in here, a two-tier supply chain with 1 supplier and 1 retailer. Down the road, I will extend this to 2 suppliers and 1 retailer, and we will see the implications of having multiple suppliers on the amount of waste in supply chain. So in here, then I can kind of look into the type of uncertainty we have in the supply chain. We have 2. One is the uncertain demand on the side of the final consumers. In here, I don't mention it because it was not in the original model, but in the revised model, consumers are also wasting food. So a layer could be added to the supply chain to capture the waste on the side of the consumers as well. So that's one side of the uncertainty. And the other one is the level of freshness of the shipments from the supplier to the retailer. So I'm going to assume a simple two-point distribution for the freshness of products. It could be either a good batch with a high level of freshness, or it could be a low quality batch with a low level of freshness. So theta high and theta low, with probabilities P and 1 minus P. So this P is going to become important down the road because I'm going to take it as a proxy to the quality of suppliers' processes. Of course, it's a crude way of modeling it, but this is how we have done it in the paper. So the higher the P is, it means the higher fraction of the shipments on board to the retailer are going to be of higher quality or higher shelf life. And the lower the P is, means we have a higher proportion that have a lower shelf life. So that's what we have as the sources of uncertainty in this model. If I put together the wastes in here, I have a waste on the side of the supplier. There is a waste on the side of the retailer, and there is a waste also on the side of the consumers that I haven't incorporated in this little model. Yes, Daniel.
Where is the theta I minus Q? So if your Q is smaller than theta I,
Yes.
right, those are overstocked.
So in case, in case Q is less than theta I, then you only have Q that's being shipped to the retailer, right?
Yes.
So the remainder of the theta I is going to go to waste on the side of the supplier.
But the waste is only 1 minus theta I, right?
This is just to show the proportional waste in the supply chain. But in the revised model, I have also included that one. So of course, in case, so we don't have, maybe you're one of the referees in the paper as well. I don't know that. So it's a very good point, right? So in case this Q is less than theta I, then we will have the remainder of this batch that remains the supplier. But these are fresh products. So we cannot store them for future shipments down the road. You will have other batches coming forward. So you will have to incorporate that waste with the supplier as well. That's one point. And another one, as I mentioned, is with the consumers. So we can also argue that on the side of the consumers, once they have bought it, there is also waste that is being affected by what the retailer and suppliers are doing. So we also had to add that component to the waste in the model as well. So very good catch. I promise you that in the revision, they are included. Okay, very good point, very interesting observation. So this is the model that we have. This is the total expression, the expression with the total waste in the supply chain. And now, so we have cooked up 3 different levels of information sharing along the supply chain. So you can imagine that there is no information being shared in the supply chain. That's our benchmark case. There is no information that is being shared from the supplier to the retailer, because supplier is the one who holds the proprietary information on the freshness of each batch, and that's not being shared with the retailer. The second one is when we have product information or spoilage information that is being shared with the retailer. So now, what happens in here is that the supplier is sharing the freshness of each and every batch that is being shipped to the retailer. So this is only information on the product itself. Now, we can also imagine on the other extreme that we have full transparency in the supply chain, which means the retailer, the supplier, is sharing the product and process information with the retailer. So the retailer knows how the supplier is handling food along the supply chain. So for example, the quality of their cold supply chain, the training of the employees, the packaging practices, and so on and so forth. In here, they don't. The only thing is that they share whether this batch coming on board has a high shelf life or a low shelf life. In here, the retailer has this window into the supplier's operations. So, and that's important because given the information, the retailer will have the incentives in order to invest in improving those processes. So that's the difference between this scenario and this scenario. Full information sharing in here, this is partial information sharing, and in here we have no information being shared with the retainer. Now, in the revision before Daniel asks, I actually have this information sharing as a continuous variable. So any level of information being shared with, could be shared with the retainer, which means we will have to see what level has to be shared if the goal is to bring down the food waste in the supply chain. But in the basic model that we developed, there is no trace of continuous information sharing. Okay, now, so we can take a look into a couple of dynamics in here. So information sharing is when, as I mentioned, the supplier is sharing the information on the product with the retailer. And information asymmetry will be one when there is no information being shared. So I'm not talking about the extreme when all the information is shared on part of the process, only information sharing on the product or information asymmetry altogether. So you're going to get to that one a bit later. Now, this one is going to be a classical supply chain setting. There is no surprising insights in here. When we have, well, under information asymmetry and information sharing, we can solve the order quantities for both the supplier and the retailer, and then see what happens, the order quantities and the amount of waste in the supply chain. Now, when the information is shared on the product only, what happens is that we have an over-ordering effect in the supply chain. So the retailer takes advantage of the fact that he knows the exact shelf life of the products being shipped to it and over-orders on average. Over-ordering on average means, because we have a proportional waste setup, it means it will have no waste in the supply chain. So sharing only product information is going to lead into more waste in the supply chain. Of course, a policy that focuses on penalizing waste is going to be effective. Always you can imagine increasing the penalty to a large amount is going to decrease the waste, but that's going to happen because the order quantities get suppressed. So that may be desirable environmentally, but it's not so good socially because that means decreasing the demand fill rate. So our goal is not in this paper to decrease the food waste at any cost. We want to decrease the food waste, keeping the demand fill rate what it was. So environmental consequences need to be balanced with social consequences. We don't want to decrease the waste at the cost of decreasing the demand fill rate. So yes, we can impose a penalty regime in this case to curb food waste, but that's going to come at the cost of decreasing food waste, the demand fill rate, which is not desirable. Okay, now let's move on to full information sharing. So when the information are being shared on the product, on the process, I will be translating this into the idea that the retailer now observes how the supplier is treating food. So, and they can invest, either the supplier or the retailer can invest to improve the quality of the processes with the supplier. So this K is the cost per unit improvement, and P, as I mentioned, is the proportion of batches that have higher shelf life. So the process could be improved at a cost of K P squared, either by the supplier or by the retailer. Well, the supplier itself can do so. If the information is not being shared, the supplier can just invest in the processes himself. But if it's being shared, then the retailer can chip in as well. So the retailer has the incentives to improve the processes on the side of the supplier as well. Now, we have a few points, and then I think I can make the key learning from the paper. The very first one is that when the full product and process information is being shared with the retailer, the quality of the processes will be the highest. Because the retailer has a strong incentives to improve the proportion of batches with higher quality. So no matter what other parameters are in the model, as long as information is being shared, the retailer has the incentives to increase the quality, and more so in comparison to the case where the supplier doesn't share the information, but he himself invests in improving the processes. That's the first learning that we have here. But improving the process quality or increasing the proportion of batches with higher shelf life doesn't necessarily mean that we will have lower waste, because batches being of higher quality encourages the retailer to order more. So we are back to the same regime. We have a process improvement effect, which is good because it decreases the waste, of course. So in case we have higher shelf life, we will have lower waste. But the point is, it also creates this over-ordering effect. So as the retailer orders more, you will have more waste. So we need to find that sweet spot that information sharing leads to a reduction in food waste. It doesn't automatically lead to a reduction in food waste. That's the key point in here. So information sharing, food process and product information sharing does not lead automatically to a decrease in food waste. It needs to be under the right circumstances to push the supply chain partners to bring down the amount of food waste. Now, we can take a look in here at the impact of the penalties that we talked about before. So the effect of penalties in here is quite interesting. So in case we have a product with low margin, let's say bananas, for example, increasing the penalty on the waste for bananas, they are a very low margin product, only decreases the process quality on the side of the supplier. So, and of course, as the process quality decreases, then the amount of waste is going to increase. As the penalty is also going high, then the order quantities are going to be squeezed. So not only you have a lower quality batches being shipped, but you also have lower demand fill rate. So we see with low margin products, penalties seem to be not really effective in doing anything. When it comes to higher margin products, such as avocados, for example, penalties have a different impact. So up to a certain threshold, they do increase the process quality. But beyond the threshold, they are going to hurt the process quality again. Of course, in here, as long as we are improving the process quality, we do have the process quality improvement effect, but we also have increasing the order quantity effect. So again, it's not clear what the overall impact of penalties would be on the waste. Now, the key thing in here is that if we have the cost of improving the process, that K parameter I mentioned before, below a threshold, so given a penalty level, given a margin for a product, if the cost of improving the process, K, is below a threshold, then sharing the supply chain traceability information is going to help bring down the food waste. Now, the key learning in here is that if we want to encourage, once the information is shared, in absence of full information sharing, as we said, these policies are not going to be effective. But if the information sharing is already happening in the supply chain, penalties do not seem to be effective in decreasing the food waste. What helps is to subsidize those technologies that are supposed to bring the traceability into the supply chain. That's the key learning here. So if this happens, then the process improvement effect is going to dominate the over-ordering effect, leading to a decrease in the food waste. So as I mentioned in here, increasing the penalty once information is being shared is not so effective. And rather than penalizing food waste, the better policy would be to subsidize traceability technologies, which is not something altogether foreign, because let's say in the adoption of electric vehicles, there has been quite a bit of subsidies provided to final consumers to encourage them to switch to electric vehicles. So those subsidies have precedence in different industries. And in here we are saying that once the information is shared, or the intention is to share the information, the best policy is not to penalize the retailers for the waste. The best policy would be to actually subsidize the technology so they can bring those technologies into the supply chain. That's the key learning, by the way, in this paper. So another thing basically in here is whether the supply chain partner, so getting to the third question now. So what we learn is that information sharing, if it is full information sharing, product and process, has the potential to lead to a decrease in the food waste. That's great, but why would the supply chain partners invest in sharing the information? Because sharing the information always is going to benefit the retailer. It's not clear it's going to benefit the supplier. What we show is that sharing the information benefits the retailer, and that creates the incentive for the retailer to pay the supplier to actually move in the direction of sharing the information. So side payments, in this case, are beneficial. So the retailers could pay the suppliers in order to encourage them to participate in sharing the information, and down the road we could face as well. And that's basically the key learning that we have in this paper. So kind of getting back to the earlier comment on Tesco, we also looked into the setup where we have a retailer with two suppliers. I'm going to spare you the details of this model. The mechanism is pretty much the same. And the idea is whether having two suppliers and the information being shared along the supply chain is going to be beneficial to reducing the food waste. And what we find is that having actually a single supplier is going to be better if the goal is to bring down the food waste. And the intuition behind this is that when we have two suppliers, the retailer will have to invest in two retailers in order to establish this traceability system. And that is not beneficial. In the balance of things, it's better to focus on one supplier if the goal is to bring down the food waste. And with that, I think we are done pretty much. So getting back to the example of Tesco. Tesco in 2017 moved from multiple suppliers of fresh produce to only one. And of course, that is encouraging to the supplier, because now the supplier is getting the orders, the entire order for fresh produce from only that one supplier. So the supplier has large scales to deal with. So they have the incentive to cooperate. But then Tesco, in return, is involved in quality decisions with which farms are you sourcing from, which transport routes you are using, the quality of the cold supply chain, and so on and so forth. So this is kind of moving towards integration rather than diversifying the supply base. And their claim is that since 2017, they have been able to decrease the food waste by 200 metric tons every year. And interestingly, customer complaints on spoilage have gone down by 70% as well. And I think the other setup provides a rationale for why this makes sense if the goal is to bring down food waste. And that's pretty much it. So in terms of key takeaways, supply chain information sharing does not necessarily lead to spoilage waste reduction. In certain circumstances, waste penalties may reduce the food waste, but the key message in here is that that comes at the cost of reducing the demand fill rate, which is not socially desirable, and reducing process improvement costs or subsidizing the technology along the supply chain could be a better strategy to bring down the food waste. And dual sourcing is not necessarily good. It may actually increase the spoilage waste in the supply chain. And again, if the goal is to bring down the food waste, a better strategy could be to switch to single sourcing. And that's pretty much all I had to share. If you have any questions, I'd be very happy to take.
Thank you.
My pleasure.